Welcome back to McChanic. Today I'm going to be bolting a couple little parts onto the motor and hopefully make that pile of boxes over there a little bit smaller, easier to sort through. And what I'm going to be starting with is replacing the pilot bearing, because I looked at it and it looks like it got hammered on a little bit when it was being installed. And even though it looks like it's okay, when the motor's all put together, that's going to be a really difficult thing to access. So just so I have the peace of mind that it's good, I bought a new one, because when I have the motor exposed like this, it's not very expensive or difficult to replace. So I went and rented a pilot bearing puller and a slide hammer. I'm going to see if I can't start out getting that done today. So I've got the pilot bearing puller threaded onto the end of the slide hammer. When it's loose, these two jaws are together. They're going to slide inside the pilot bearing, and then I'm going to tighten it down, and then these will then grab the inside of it, and then just the motion of the slide hammer hopefully will pull it out the back. Alright, maybe I should have asked if they had two sizes of this, because this guy does not want to fit inside of there. And I tried manipulating it back and forth in different directions and couldn't make it happen. So I think what I'm going to attempt is pull off this rubber O-ring and just put one of the jaws in there and hold force against it on one edge of the pilot bearing and then try anyway. Okay, I'm using my trusty floor jack as my camera stand. So I'm going to try to just get one of these in there and hold pressure against it. It's not working so far. So I really didn't feel like driving 35 minutes back to the auto parts store to see if they had a different size. So I did a little hokey bolt inside of there with it, and it seems to be working. All right. Well, wasn't the way it was designed, but I made it happen. So a common way I've seen people install pilot bearings is by getting a socket that is the same diameter as the pilot bearing and then just hitting the back of the socket with a hammer to drive it in there. But this seems like pretty soft metal to me, and I want to avoid metal on metal contact if I can, so I don't cause any distortion or misshape to the new one I got. So I got some non-marring hammers with soft heads on them, and I'm going to try to knock this in there with a little bit of finesse if I can. If I can't, I may have to end up using the socket method anyway, and hopefully I won't end up damaging my new pilot bearing. Well, that way's working pretty good so far, but now that I'm underneath the lip of the crankshaft, I'm having trouble hitting it with perfect accuracy, and so I'm hitting the crankshaft a lot and not actually the pilot bearing. So what I'm going to do is try to hold my non-marring hammer there and drive the back of it in with a little more oomph. And if that doesn't work, I might try a wooden dowel or something like that, but I'm going to try to keep metal to metal as my last resort. So that method seems to be working pretty well. I just have a little bit farther until I get it all the way seated, and I should be good. So I was able to get it installed nice and flush. The last about 1/16 of an inch or so, I think the plastic on these is just too soft and it wasn't allowing it to go all the way in. So I employed this closet rod and used that with the assistance of a hammer to get it all the way in there. When installing a pilot bearing, there's the front side that has kind of a rounded inner edge, and there's a back that has a square flatter edge. And you always want to make sure it goes in the proper way, because one, if it goes backwards, the bearing puller is not going to grab this rounded edge very well. Not that I had much luck with my bearing puller anyway. And then also, when you're doing your transmission stab, the input shaft will slide on this tapered edge much more nicely than trying to enter into a flat edge like that. All right, the next thing I'm putting in are the knock sensors. They take a 7/8 socket and they get torqued to 15 foot-pounds. So they just screw in here and then I'm going to torque it down. That's about it. And that's it. So yesterday ended up being a learning experience for me. The next thing I was going to install was this steam vent kit from Earl's. And when I went to do it, I realized that the passenger side rear port was plugged. And so I tried to remove it. I ended up knocking it into the engine, which was not fun, because then I had to learn the proper sequence of disassembling the valve train and taking the head off, and the proper order of operations for what bolts to remove in what order, and then how to retorque all of it and reset the valve lash. And I learned a lot of things, including that all of these intake rocker bolts need to be sealed with RTV, because since my heads are ported, that hole is exposed at the bottom there and on the intake side. And so there would be potential for oil to seep in from the rocker bolt and get sucked right in to the intake side of the head. So I RTV siliconed all those. Anyway, what I discovered was there's not even a water jacket connected in the block on this specific block. So I still got this plug removed. Apparently GM has some motors that include it and some that don't. So I'm still gonna install this kit the way it came, and this backside will just deadhead and the other three will function. First thing I'm doing is just taking some parts cleaner and a rag, and I'm just cleaning off the surfaces where the steam vent is gonna seal to. So I've got it assembled to this point. The center block I have everything tightened down on, and I have all the end fittings tightened on there. And then what's gonna happen is this will, it's hard to do one-handed, but that'll get held in place with that mechanism, and then this will all get tightened down in the four corners, and those will get tightened down to 65 inch-pounds. There's the kit all installed, corners torqued down. The last piece to go in is going to be the outlet here out the front, and connected to that is going to be this hose, which is cut to length, and it comes with this little fitting, which I am going to connect to my water pump. And the reason I'm doing this is because, unlike some older motors where the water outlet on the motor is at the highest point in the cooling system, the water outlet on this motor is down at the water pump below where some of the coolant passages are. And so there's a potential that a little vapor pocket or air pocket could occur and get trapped in there and cause a hot spot in the motor, and you don't want that. So this gives it a place to escape from all the highest points and then route out the front. And mine's gonna go to the water pump, like I said, but it could also go to somewhere in the radiator hose, straight to the radiator. And so I think this is a pretty slick little kit. It'll fit nicely underneath my intake manifold, but stay out of the way. And that's it for today.